Okay. That was only part two. Yeah.
You stopped and started it.
I haven't been filming the whole class.
Alright, ready? Is it on?
Yes.
Alright, we're back. Let's look at the two names. We have established that every surface has its own coefficient of friction. We saw the cup went swinging across the table when it was just the cup, but when we changed the surface to tin foil, it hardly moved at all. So every surface has its own friction number. We're not going to call it friction number, we're going to call it coefficient of friction. Every surface has two coefficients of friction, one for when it's still and one for when it's moving. What should we call the still one? We will call it the coefficient of static friction. Sounds like a big fancy name, but the concept is simple. It's the number associated with the surface when the object is still and you have to push it from standstill. Coefficient of static friction. It has a symbol, but I'll give you the other name first.
Is it kinetic?
It is. Oh! Have you heard of this?
Yeah, we learned it with Mrs. McManus.
Okay. Coefficient of kinetic friction. If you can remember static and kinetic, it's easy to tell which is which because still starts with an ST and so does static. So static is still. Coefficient of static friction and the coefficient of kinetic friction for every surface. Wood, it has a static friction coefficient, it has a kinetic friction coefficient. Plastic, same thing. Metal, same thing. Sandpaper, same thing. So, the symbol, did she teach you the symbol?
If you show
All right.
it, I can tell you.
The symbol is mu, and mu is a...
M in Greek.
It's like a Greek fancy letter. So it kind of looks like this. When you see it, it almost looks like a U, but it's really an M.
We all took Greek, so.
Pardon?
We all took
All right.
Greek.
So
Except for me.
You probably do
Well,
better
And
than
Alex
I
didn't take Greek.
Oh, yeah, Alex.
do. All right. So does that look like
Hunter didn't take it
does
either.
that look like
Yeah.
a U to
What?
you? It's really an
It's supposed to be
M.
the other
And
way.
so static friction is M sub S. So guess what kinetic friction is? M sub K.
Where's the M?
No,
It is an M.
That's looks like Y to me.
Yeah, it looks sort of like a Y or a
It's a moon.
U.
It's called a moon. I mean,
It's called
Mu.
mu in Greek. So if you write on your
Why in
paper,
Greek? Why in English?
they chose
Just wait till you
Greek
get to
letters.
calculus.
If you want to
There's
use
no English.
M sub S, you may do that if you don't feel like doing the fancy Greek. I tried to mimic the Greek.
Wouldn't that be like meters per second?
Yeah, it looks like it.
So
Yeah, maybe you stick with your mu. All right.
just draw an M.
M
with,
sub, I
like,
call it M sub S,
Looks
but
like a
it's
bridge.
really mu sub S and mu sub K. So I'll try to say it the right way. All right. Now we are ready to give you the. This is all theory. Any questions about the theory? It's pretty understandable. We deal with friction and sliding things all the time. So let me give you a formula. Formula for friction. F sub F. Notice I call that the force of friction. F capital F, small f for friction. So this means the force of friction equals ms or mk. Let's say the object is still. There's two formulas. Object is still. When the object's still, the force of friction is different than when it's moving, which we already exemplified. So the force, say the object is still, force of friction is m mu sub s times force normal. All right, surprise phase. There it's back again. I told you, there we go. I see mucho surprise. So when the object is still, the formula for the force of friction is mu sub s times force normal. Force normal is normally just mg with the opposite sign, but sometimes when we change the surface, like when with an inclined plane, it will not be mg anymore. It'll have a sine or a cosine, like everything on an angle. So I'm going to call it force normal. Some years I've taught it MSMG. That's not true in all cases, so I'll be true to you. So, all right, and then guess what the equation is when the object is moving? Force of friction equals mk, m force normal. Mu sub k, force normal. So there's two equations, whether it's moving or whether it's still. So, we're all set to do a problemski. Let's see. Draw a log, a big old log, with a chain around it. The log's on the ground. There's a chain pulling it, and a truck is hooked to the chain. So we have a nice big log. And we'll do a friction problem here. A first friction problem. Get rid of some of these notes. So the log happens to be 300 kilograms. 300 kilogram log. Here's the chain.
Taking my pet log for a walk.
And here's the truck. That's where my drawing falls short. Alright. Here's the truck.
Wait, I'm still drawing.
So. Find the force of friction the truck has to overcome
Whoa.
to start the log moving. What's the matter?
Our game was just like tractor trailer, let's
Wow.
go.
Need to put, you have the drawing on the board. Before we start and I write out the problem, someone has studied log and ground, and so they know that combination. Mu sub k is 0.45. Mu sub s is 0.75. Will mu sub s always be greater than mu sub k?
Yes.
It will. So I'll go over here and actually make a note of that. Here, coefficient of static friction, because the object's still, is always greater than the coefficient of kinetic friction, because it's easier to push it once it's pushed than from a standstill. So and one day I will go up here and I will mix these up. I will go up here and say m sub k is 0.75 and n sub s is 0.45, and you guys raise what you're supposed to do when I put something wrong on the board, which is about every other 30 seconds. Raise two hands. Raise two hands. So then I know that I've done something wrong. So. Alright, so one day I'll come up here and do that, because I won't be looking closely, and you can raise two hands. Because MK is always going to be the smaller of the two. MS, the larger. Mu sub K, mu sub S. Here's the question. If we don't finish this question before, well, I haven't heard the 5-minute bell yet, but we're going to be in the middle of this, I'm sure, when the bell rings. So there will be no assignment tonight, so we'll just come in tomorrow bright and chipper and ready to finish these up in class. So, and that'll be it before the break. This will be the last topic that we cover in this mod. All right, so here's the question. Find the force. Find the force of friction. May I use this symbol? Find the force of friction. The truck overcomes to move the log. So once you've sketched that and written down the question part, or what we're looking for, I will work it out for you.
Oh yeah, what time is it? We should answer that. Maybe we should because it's the only time.
So, in these 5 minutes, see if we can get this one done and another one set up. Emily, number 1.
What's that mean today?
Will we be using this formula or this one on this problem? We have to pick one or the other.
M's of K.
Pardon, MK?
MK.
I'm going
Okay.
to assume that the log is still. So the
Oh,
problem
okay.
should tell you that. So your guess was good as mine actually. Unless they say differently, I assume it's still. So we're going to emphasize that. So F force of friction equals MS. Oh, I know what. I know, I probably didn't need to tell you that because the way it's worded, find the force of friction the truck overcomes to move the log. So I think to get it started moving, it's kind of implied in the words that it's still. So I probably wouldn't have to tell you that. So it's either going to be strongly implied or actually told to you. So you'll know clearly which one to go with. All right,
So the log is 10 grams or 300 kilograms?
it's 300 kilograms.
That says log, not 10 grams.
Oh.
300 kilograms. There, is that clear?
Yeah.
All right, force of friction is what we're looking for. We're going to grab mu sub s is 0.75. And then we've already been well taught how to find force normal. So force normal is the opposing force of weight. So how do I get the weight of this log? Review it for me, Emily, number 2.
You take the gravitational constant and multiply it by the mass.
All right, and which gravitational constant am I going to use for
Meters.
kilograms?
Meters.
I mean the gravitational constant, what number?
Oh, 9.8.
Pardon?
9.8.
9.8, right. All right.
Is that negative?
Since we're looking for force of friction, it is a vector. We will need a direction, but we also know that force of friction always opposes motion. So if we are going to find the motion of the log this way, then at the end we're going to call friction negative. Or you can use the words in the opposite direction of the motion. So negative is relative, so force of friction should be applied that it's opposing the motion. What is that number? Anyone got it?
2,205. What?
2200?
Yeah, 22.
That's right.
All right. 2 sig figs.
Yep, huge significant.
So force is in like pounds or newtons.
All right, so what units do we use? Since force is a friction is a force, so it's either going to be newtons in metrics or it's going to be pounds in America, the English units. So force of friction is 2200 M. Before, we won't do another one, but let's just talk about what would be the unit. I taught mu sub s and mu sub k, but I didn't tell you that's unit. Can you look at the value? Now that we have this answer, we know that that goes there. Force of friction is 2200 newtons. So does that help? Because we know this was in kilograms, so I'm going to smush in a kilogram. We know the units for acceleration to gravity is meters per second squared. What was the long version of Newton? Do you recall?
Kilograms per mass over second squared.
Yeah, kilogram meters per second squared again. So I'll use the long version. So if we have kilogram meters per second squared on this side of the equation, there's an equal sign, and kilogram meters per second squared on this side, what must be the unit for the coefficient of static friction? Any thoughts? I mean, if I say pounds, it wouldn't match, because then I'd have a different unit here and a different unit here. Well, the answer to that is it is unitless. It has no units.
Okay.
All right, so we can make a note of that also over here.
So it's just 2,200?
Well, that had an answer. That was a force, so that was in newtons. But now my second question, what is the unit for the coefficient of static friction? And it has no units, neither of them, the kinetic or the